So this is a continuation from my last video, which was about the bike rental demand estimation. So you can check out my last video to see the exploratory data analysis of the bike rental data set, and I have also explored the data set and plotted different scatter plots and box plots to see check out the outliers and the feature distribution, feature similarity, and I've utilized statistical features. So I've also split my data set into the train and the validation data set. So in this video, I'm going to explain you about different data algorithms, basically regression algorithms, which will be used for predicting the bike rentals and what would be the rental estimation and the rental demands in the future. Mm. So this is the Lasso algorithm, and I'm using it to see the bike rentals. And in this algorithm, basically, when you have the data, then it tries to fit the actual and the predicted values, and also it calculates the how close the values are, and it tries to find the error. And basically RMSE, it gives you a exact value of the of how predict accurate your results are, and R square, like between it lies between 0 to 1, and like if it tells you about the loss or the data loss, um, and every time the R squared value is too high or like closer to 1, then you say the loss is too high, and the predictions are not so perfect. And if it is here, if we say that RMSE values are, it gives you it tells you about when you compare different models, like which model is predicting well. But it I totally feel that it is a hype metric, and it actually it creates confusion if we just see the values. So I've also used a decision tree regression decision tree, because decision tree regression, it has different kinds of leaves and branches. It uses the Gini indexing and the entropy values to see the purity, and also every time whenever you use decision trees, then you can visualize your decision tree as well. Here I'm using the tree visualizer from sklearn or scikit-learn, you can say. So there are a lot of features, and it tries to show different kinds of branches and truncated values. So similar to a tree, every time it has a opportunity of overfitting. So greater the data, every time when it tries to calculate the impurity values, then you can see the value over here. You see, every time you see that root node is calculated based upon the decisions of the leaves. Mm. And it has a condition of overfitting when most of the branches get pruned by below decisions, and you see the R square goes negative here. And we saw that most of the rentals were between 0 to 500, but you see the prediction value over here, it actually goes beyond 2000 as well. And between 1250 to 2000, you see there are less values in a particular manner. Here the decision tree, I'm using the same code for decision tree as well. So the model is actually predicting, and when you see the visualization, it's actually closer to the actual data value. And actually the outlier values between 1250 to 2000, it also is lesser data points. And we see close that the estimation here and in the scatter plot, it is closer to the real values. And the tree model, though it doesn't seem to improve the actual predictions, but if you keep training the model, then and also tuning the parameters, then the performance might be good. But we also have random forest. It's another model where there is a condition of overfitting or pruning or cutting of the branches, or problems in making decisions is not faced by ensemble algorithms trees. Basically, in ensemble algorithms, you can say it's like taking a bunch of chard leaves or spinach leaves and bunching them together, like keeping so many bags of leafy vegetables together, and all these bags of vegetables, they are used to they actually decide which vegetable is the root vegetable. So you can also say, like, if you have so many people who are living in a village, and they try to elect their panchayat raj, or the leader of that particular village, then all these people try to vote for that particular person. So all these people can be seen as similar caste groups or similar genders or similar communities. So all these communities are called as small bags in the random forest. So randomly they select a particular leader, and uh, the process of actually coming together and building the tree is called as bagging. And the process of building the decisions, that is one upon the other, like the various categories while choosing the leader. Like they see sometimes if the income level is good, if the person has experience in ruling party, or if the person has ruled before, and the reputation of the person, or how useful it is. So the decision after the decision on they keep the trees, it keeps building decision upon decision. So that process called as boosting. So you can also visualize a pineapple tree, or a Christmas tree, you can say. Like Christmas tree also grows from one part. So you can remember random forest like a Christmas tree. And the process of building and decorating the Christmas tree from the bottom to the up is called as boosting. You can remember like that. So in random forest, we see several kind of trees come together, and um, it gives you a decision. So if I'm explaining it in a wrong way, you can actually correct some of my words, or the explanation about the tree in the comments below, and also leave some nice comments and reviews for me. And this is about you can see the scatter plot for decision tree and for random forest is actually quite different. And we saw that the frequency count was up to 2000 before in the decision trees, but here it is between just the actual labels are 2000, and the predicted labels are like 1600 to 1400, 2000, like that. So we actually have a in the previous one, r square was minus 0.54. This was more accurate, and in here r square is 0.152. There is some kind of mismatch in the predictions, and we have to improve this model as well, ensemble model. And there's another model called as a gradient boosting estimator. In this particular gradient boosting estimator, it is similar to the random forest algorithm, but in this particular algorithm, um, like um, every time we take a in random forest, many particular people on many trees, they take the decision of choosing the leader. And the leader, like when we decide our CM, then many people they take the decision to elect the CM and the MPs and the sorry um, sorry when we usually elect a ruling party member, then sometimes many people take the decisions and voting is taken for choosing the member. But in gradient boosting estimator, a real time example is the ruling party members, whoever are there inside the team, and the strongest members, then they try to choose the member based upon the results of the previous ruling party, or just by seeing the like the performance of that person in the last year. And it is also similar to like when a person is working in a company, then like the promotion of that person to the next level as a senior manager or a vice president, it happens only inside the company sometimes, and the decision is taken immediately by the superior. So gradient boosting estimator is similar to that, and the decisions of the new members is done by the previous members, and only based upon the outputs of the previous trees the new tree is constructed. And it is actually done so that there is lesser loss to the company and lesser errors in the model. So similarly in this notebook also I have written that it is reduces the loss of the model. And like you can see, the in this ensemble tree, the actual labels are actually going till 4000 or 2000, but the predictions are only till 1600. So we have lot of loss here. So to reduce the loss, we are using the gradient boosting estimator, and this is another kind of model. So this notebook's actual target was to use different kind of regression models. So here you can see the predictor labels. We see that prediction labels are actually only till 800, but the actual labels are till 2000. And since the data was till 2047, and there were many outliers which I did not clean, and even the one hot encoded labels were there, and this was our first cycle. And we see that the gradient estimation, it actually uh, reduced the error in somewhat in 0.147, and this is 0.152. But we see that the actual labels are actually not predicted labels are till only 800, and this is even half than 1600. So gradient boosting estimator did not work properly over here. And the person who took the decision, the senior person, actually did not take a good decision. And this actually did not work well with the model, and that might be because we did not clean our outliers in the data set, and it resulted in a lot of variance values, that is a confusion kind of a confusion. And variance is basically a biased decision, and you see that the values are only till 800, and all the values which were till 4000 predicted values are missing here in the in this particular gradient boosting regression. So we can I've actually tried to experiment with different models, and I have actually plotted these values also over here under scatter plot. So you can see the decision tree, it was performing very well. It had till 2000 predictions, and you can see if I keep a wallet later. Scrolling to the top, I could actually improve, like I could click on the cell, but this is one of my saved version. So the worst performing tree was the Lasso model, and the linear regression model also, it had 600, and same with the Lasso model. So the best performing was, first goes to decision tree, second is random forest, that is the ensemble algorithm, and the third is the gradient boosting regressor, which had till 800, and the fourth is the linear model, and the fifth is the Lasso model. So based upon this scatter plot, I have ranked the models prediction values. So similarly, if I want to like compare the models, I can use a pipeline, and I can execute one model inside another model, because the data training validation test set is same. So I'll show you how hyperparameter tuning and pipeline for machine learning models can be built in the next video. Bye bye. See you soon, guys. Check out my other videos on Azure Cloud and GCP. I have made videos about coding, about partitioning data, and also building Hive tables, how it is used in the Azure Cloud data space. And you can actually load your data to ADFS, that is Azure, and how it is done I have made few videos. You can check out the links above. Stay cool. Bye bye.